Now in the second part, it is given that instead the table is rough and the coefficient of friction between A and the table is 3/8. Find the total distance covered or traveled by A, and you may assume that A does not reach the pulley. So in order to find out the total distance covered by the particle A, first we need to assume the different forces acting on the particle A and the particle B, and from forming equations we will be figuring out that what is the value of the acceleration of the whole system before the point B or the particle B hitting the ground. So first of all, we need to take into account the various forces which are acting on the particle A. The first force is, of course, the force of tension in the string, and that is acting on the particle A, and the other force is the force of friction, and the force of friction is mu r. So the resultant force at the point A or on the particle A will be equal to T minus mu r, and according to Newton's second law of motion that will be equal to ma. Now T minus mu is given, it is 3/8, and r is equal to the weight, and the mass is 1.6, and it will become 16 when you multiply 1.6 with 10, so it will become 16, and that is equal to m. M for A is 1.6, and that is A, and this will become T minus 6 is equal to 1.6A. That is equation number 1. Now we consider the particle B. Now there are again two forces. One is acting in this direction, that is the tension, and the other is downward, that is its weight, and the net force on B will be equal to T minus W, or rather it is other way around because the motion is in the downward direction. Therefore it will be W minus T is equal to ma according to Newton's second law of motion, and W for the particle B, its mass is 2.4, will be 24 minus T is equal to m for particle B is 2.4 and A. So solving these two equations, that is equation 1 and equation 2, you will get the acceleration of this whole system, and that is equal to 4.5 meters per second square. So this is the expression of A or B or the whole system, and now we will be finding the velocity with which the particle B hits the ground. So let us form a data for the particle B. Now the particle B is initially at rest, that is u is equal to 0, and its acceleration is 4.5 meter per second square. Its final velocity is required, and it covers a distance of 0.5 meters. Now we will be using equation v square is equal to u square minus v square minus u square, rather. V square minus u square is equal to 2as. Now putting all the values, in this equation you will get the value of V, and that will be equal to 2.12 meter per second. So this is the velocity with which B hits the ground. Now when B will hit the ground, this string becomes slack. It will lose its tension, and the only force which will act on the particle A will be the resistance, force of resistance. So when the B hit the ground, the situation at the B is that it will be only affected by one force. So that is mu r. So mu r, this is the force of friction, is the only force. According to Newton's second law, this is ma. Now from here we can able to find out the value of A, that is the acceleration produced by the particle A. So what is the acceleration of the particle A? So we know that R is same as W, and it is mg is equal to ma. This m is cancelled with m, and you are left with here mu g. Mu is 3/8 into 10, and that is A, and you will get A is equal to 3.75 meter per second square. Now this is the acceleration of the particle A when B hits the ground. Now as you can see that the prior acceleration of the particle A was 4.5. So when there is only one force, and this T force is now finished because there is no tension in this string. So the acceleration of the particle A is reduced from 4.5 to 3.75 meter per second square. Now we will be moving towards finding the our requirement, and that is the total distance traveled by A. Now the scenario becomes that the acceleration of the particle A is 3.75 meter per second square, and its velocity will be the same velocity as the final velocity with which the B hits the ground. When B hits the ground, the point A, or the particle A, will have its initial velocity, and that velocity will be 2.12 meter per second. So velocity will be, that we said, initial velocity of the particle A will be 2.12 meter per second, and its final velocity of course will be 0. This all data is about the particle A. Now we will be using the equation V square minus U square is equal to 2as in order to calculate the distance traveled by the particle A. Now the final velocity of course is 0 square minus the initial velocity is 2.12 whole square is equal to 2, and the acceleration is this is a decreasing, this is deceleration in fact, so therefore it is minus 3.75, and s is our requirement, the distance traveled by the particle A. And when you find out, when you calculate the values, you will get s is equal to 1.009 meters. To 1 decimal place correctness, it should be equal to 1.1 meter. So this is the distance traveled by the particle A when the B hits the ground.